We are going to our next topic, model evaluation using Python in data science. So model evaluation access a machine learning model's performance on unseen data to ensure it generalize well, and here is how can perform evaluation using Python. So it can be performed by two. So hello everyone, we are going for our next topic, model evaluation using Python. Model evaluation access a machine learning model's performance on unseen data to ensure it generalize well. Here is how you can perform a model evaluation using a Python. By some methods we can modelize a model evaluation using Python. First is split the data set. Second, second is train the model, and third is evaluate on test data. Fourth is cross validation. So these are the methods of model evaluation. So so model evalution so model evaluation accuracy matrices, understanding the classification or accuracy using a model evaluation using Python. Accuracy. So the most of the accuracy matrices, understanding the classification of accuracy using a model evaluation using Python. Accuracy. The most inactive matrix, accuracy measures the proposition of the correctly classified in sentence. It is often expressed as a percentage. Accuracy, the formula of accuracy is true positives plus true negatives equal to divided by total instance. So second is precision and recall. So precision measures the proposition correctly and predicted a positive instance among the all predicted positives. Recall measure the proposition of correctly predicted positive instance among all the actual positives. So precision is equal to true positives slash divide by true positive plus false positives. Recall true positives divide by true positive plus false negatives. And the last one is F1 score. The F1 score provide a balanced measure that combines the both precision and recalls, with particularly useful when dealing with unbalanced data sets. So F1 equal to 2 into precision into recall divided by precision plus recall. So with next the confusion matrix visualization the prediction error. So there will be two possibilities. First is actual positive and second is actual negative. So in a actual positive, predictive positive, positive, true positive, and second is predictive negative, false negative. And in actual negative, predictive positive equal to false positive and predictive negative equal to true negative. A confusion matrix is a powerful tool for visualizing a performing of the classification model. It provides a clear breakdown of the model prediction, highlighting how it can be categorized instance into the different classes by analyzing the different components. True positive and true negative and false negative. We can identify the model strength by weakness and help us to understand by where it might be making error, how it can be improved. So handling imbalanced classes or equal to, it means addressing unequal error. So unequal error cost, first is unequal error cost, second is oversampling and undersampling, and third is the cost sensitive learning. So in a unequal error costing, in a real world scenarios, misclassification have different cost. For example, a fraud detection, a false positive flagging, a legitimate transaction. It might be a less severe than a false negative, missing a fraudulent transaction. So it is an unequal error cost. And the other is oversampling and undersampling. These techniques can be applied to address imbalanced data sets. Oversampling replicates minority classes instance, while undersampling removes instance from the majority classes. Another is the cost sensitive learning. These approaches assign different weights to different types of error, penalizing cost misclassification more heavily, thereby guided by the models to prioritize actual accuracy in a critical cases. So the last is the cross validation, estimating model generalization. So there will be three types. First is three scenarios. First is model generation. Second is k-fold cross validation. Third is performance evaluation. So in a model generalization, at a model ability to perform well on unseen data is known as generalization. A cross validation helps to estimate this generalization capabilities. And in a k-fold cross validation, a common technique where the data is divided into k folds. This model The model is being trained on k1 folds and tested on the remaining folds, repeating the process for the each fold. And the last is the performance evaluation. After the cross validation, the average performance of the all the folds provided by a k folds cross validation, a more reboost estimated of the model ability to generalize the reducing impact of the data basis. So the rest of conclusion of the model evaluation. So model evaluation is a critical step in the machine learning with workflow. By understanding the key matrices, visualization, prediction errors, and empowering techniques like cross validation, we can gain valuable insight into our model's performance. Always remember to consider the context of the problem, the potential cost of the different types of error, and the importance of the ensuring of our model generalizing well to the unseen data. By this following practice, we can build a more robust and reliable machine learning model that delivers real world values. So this how the model evaluation using a Python.